Hi, I'm Steffi. Today, as a knowledge management expert, I will talk about how can we use AI and expert systems to support sustainable livestock farming. Livestock farming in Malaysia is now facing three major challenges. First, climate change is causing extreme heat stress and bringing in new disease patterns. Because of the climate change, we are also seeing a rise in zoonotic diseases, and this can threaten both the animals and us. And finally, with the current labor shortage, monitoring livestock manually is becoming much more difficult. So, how do we solve this? As a knowledge management expert, my solution is AI. We can achieve this by using three technologies. First, smart sensors and wearables. Think of this like smartwatch for livestock. They can continuously monitor data like body temperature, movement, and feeding behavior. Because this device helps us catch disease early, we can treat the animals early. And in that sense, we cut off the spread of the disease. This reduces livestock losses and cuts down on unnecessary medicines. Second, we have computer vision. Instead of relying on manual checks, smart camera systems automatically watch the herd to detect any abnormal behavior. This eliminates the needs for human labor and allows farmers to respond quickly to sick animals. Finally, we use predictive analytics. By combining real-time farm data, weather data, and disease history, AI can actually predict disease risk. This means farmers can take preventive action before an outbreak even happens. An expert system can also contribute to decision making on the farm. First, you might be wondering, how is the expert system in this context? Actually, the expert system in this context can store comprehensive veterinary knowledge as logical rules, and it can help farmers make quick, standardized decisions without needing a vet on site 24/7. Let me give you a practical example. The system's inference engine might use an if-then rule, such as if the animal has a fever, reduced appetite, coughing, and the farm has high humidity, then there is a possible respiratory disease risk. The system would then output a suggested action, which is isolate the animal immediately, improve farm ventilation, and contact a vet. This can turn complex veterinary intelligence into actionable steps for local farmers. To build an expert system, you must follow the life cycle. The life cycle involves seven phases, which are problem identification, knowledge acquisition, knowledge representation, inference engine development, testing and validation, implementation, and finally maintenance and updates. Out of these seven phases, the most critical one to me is knowledge acquisition. In this phase, developers will collect knowledge from experts like local livestock farmers, veterinarians, disease guidelines, and farm records. The reason why this is the most crucial step is that the entire expert system depends on accurate veterinary knowledge. If the knowledge we acquired is wrong, the logical rules and the final recommendations will also be wrong, which could be fatal for the livestock. As researchers note in their research, without accurate knowledge, the entire system will fail. Here are the references that support my research for this case study. Thank you very much for listening, and I wish you a good day ahead.